Welcome back to Smart Architectural Programming, your companion to mastering Java through structured and smart content. Today we're diving deep into the fundamental but often misunderstood topic, the protected access modifier in Java. This video accompanies the Introduction to Java book published by Smart Architectural Programming, adding clarity and visuals to reinforce your understanding. So without further ado, let's get started. So when we're talking about a protected access modifier, first we need to understand what it is before anything else. So in Java, you have 4 access levels: public, protected, default, no modifier, and private. Among them sits right in the middle the protected modifier. And I want to remind you, we've covered this topic a couple of videos ago as well, but we're revisiting it for a certain important aspect to it that we need to cover a little more deeply. So as you can see, protected members are access, and this is something from the previous video. The gist of the previous video that we reiterated multiple times was that it's accessible within the same package, just like default access, right? But also accessible in subclasses even if they are in different packages. As you can see the code here, which is package animals, public class animal, and protected string sound generic sound. The sound field is accessible to any subclass of animal even from outside the animals package. That's the key difference between protected and default class. I won't go into more detail because we've already covered that in a previous video, and we need to focus on other recent concepts in this particular video. So how do you represent protected members in a UML diagram? If you're not familiar with UML diagrams, they're class diagrams where visibility is denoted by certain symbols. We use plus for public variables, minus for private variables, hashtag for protected, and the squiggly line, at least that's what I call it. If you have the official terminology for that, please let me know in the comments below. And the squiggly line for the default private package private variables basically. So as you can see on the other side, we have a particular UML made here. It says plus make sound void, right? Plus means that this is a public variable or public method, and hashtag sound string, sound colon string is basically depicting it's a protected variable. This tells us it's accessible in the same package and by subclasses in different packages. So how do you declare a package with protected members? Let's create a simple package called shapes, as you can see on the screen, with a base class that has a protected member, right? We have protected double area and protected void calculate area, which is a protected method, right? So this area field and calculated area method can now be accessed by any class in shapes or subclasses else. Let me actually emphasize this a little more. So if we bring our pen here, so we have this particular portion, which is the area field, which is protected, and we have this method that's protected here in this particular case here. So this is what we're referring to when I'm talking about here. These two can be accessed by any class in shapes or subclasses anywhere, right? And how do you access protected members from another package? This is basically how you'll access a package, protected members within a package, within the same package. How do you do that in another package, right? You see the code here. In a different package, you can still access protected members if they are a subclass of the original class. Here, as you can see, we have the package geometry, and we're importing shapes.shape here, right? And we are declaring a variable called circle, which extends the shape class that we declared previously. So it's a subclass of the shape class that we declared in the other package. So here circle extends shape, and even though it's another package, it can use the protected area field and method. Now now that it extends shape and has become a subclass, it can use the private protected variables easily here without any issues. But there is something that you need to remember. Focus on this overlay note here. This is an important aspect that you need to understand. A non-subclass in another package cannot access the protected members. That's an important note to keep in mind in another package. So with that understanding out of the way, let's focus on the next thing that we need to cover in this video, which is pattern matching for switch with protected members. So as of Java 17, we can combine protected access with pattern matching for switch to build expressive and more secure class hierarchies. If you're not familiar with hierarchies, they're basically systems through which the structure of command or what supersedes the other in programming. But in simple terms, in business, it's if there's a CEO, how many people does the CEO oversee, so on and so forth, right? And it's a similar concept in programming as well. Which particular function, method, or logic takes precedence over the other, right? So let's suppose we have an abstract class hierarchy using sealed classes and pattern matching, as you can see in the screen here. This code base is what it covers all of the things that I just mentioned here. As you can see in this code here, the evaluate function, which should be right here, which is a protected function here. So if you take a look at that, you'll understand. So this evaluate function here, it uses pattern matching for switch and accesses protected methods within the same hierarchy. So it's accessing left, it's accessing plus switch right. As you can see here, let me see. Where's left and right here? We can see left and right here, and they're protected variables which it's able to access. This makes your design both powerful and encapsulated. So I think that was what we needed to cover in this particular video. To wrap up, the protected member modifier is more flexible than you might think, especially when you combine with modern Java features like pattern matching and sealed classes. This was a companion video for our introduction to Java book, published by Smart Architectural Programming. Make sure to check out the book for more detailed examples and exercises that might help deepen your understanding of these topics that we cover in these videos. Like, subscribe, and drop your questions in the comments below. And don't forget to hit that bell icon so you can never miss a Java deep dive video from us. With that, I'm going to wrap up, and we'll see you in our next video. Thank you.